Good morning, everyone, and welcome to our third REFLOW webinar, a series of talks focusing on making cities more circular and regenerative. My name is Erwan Moison. I'm director of Ecovala, a consultancy focusing on circular innovation and capacity building, and I will be your host for this session. So today we'll be exploring how digital and data solutions can support the transition to circular cities. We will be hearing from practitioners, from experts about the potential of digitalization for circularity, and we'll discuss together how to scale up these approaches to make European cities more sustainable. But in terms of agenda, we'll be having, beyond my first introduction, the chance to hear about REFLOW OS. So Adam Burns from Dime will introduce us to REFLOW OS. That is one key outcome of the REFLOW project. And REFLOW OS is a new operating system, basically creating federated economic networks in distributed value chains. Next, Stefano Bocconi from VAR in Amsterdam will show us how concretely REFLOW OS is being implemented in the city in the context of textile material flows. And following that, Enrico Bassi from OpenDot will also tell us about their experiences about using REFLOW OS in the context of municipal food waste. Last but not least, Stefan Sipka from the European Policy Center will sort of zoom out and reflect on how digitalization for the circular economy is currently being tackled at EU level. So in terms of practicalities, feel free to use the Q&A feature during the presentations to ask direct questions to the speaker. They will basically reply after their own respective sessions. We'll also dedicate a few minutes at the end of the session to answer some final questions. So as I mentioned earlier, this webinar is part of the European project REFLOW. So I will first introduce you to the project and the context in which we are operating. So where are we? We know that in the last 50 years, we've been exponentially growing from an economic perspective, but this has had obviously an impact in terms of environmental aspects. So CO2 emissions basically rising by 150%, losing biodiversity by 60%. So we know that basically we are reaching a point where a lot of planetary boundaries are at risk, and that our own system, Earth system, is also being at risk. So we need to sort of change our operating system. We need to change how we produce and how we consume. And one way to do that is to transform our economy, and also looking at how we can design and govern our cities in a better way. Why cities? Because they are somehow a hotspot for impact. We know that they occupy 3% of the global land surface, but they also consume 75% of global resources. And at the same time, they produce up to between 60 and 80% of global greenhouse gas emissions. We also know that cities are growing, keep on growing, and it's expected that by 2050, 60% of the population will be living in cities. So we need to sort of, redefine how we make cities more circular, more regenerative, and waste-free by design. Why? Because we know that we can also, through that kind of approach, provide cost savings, resource savings. We can create jobs, but mainly we can just, have the possibility to live in a more healthy, inclusive environment, and also be more resilient to external shocks. So that's basically the context where REFLOW is operating. So REFLOW is an EU project that has been funded since 2019, and it's currently in its last 6 months of implementation. And its aim is to understand and transform the urban metabolism through analyzing material flows and co-create sustainable strategies at city level. So more concretely, we have an approach that is based on international research networks. We are working together with different stakeholders, and we aim to create and scale different solutions to implement circularity in those cities. One major aspect is that we rely on Fab Labs and community production space to actually use those spaces as a testing ground to involve all the different stakeholders and implement circular solutions. We are working with 6 pilots: Berlin, Amsterdam, Milan, Vejle, Cluj-Napoca, and Paris. Each of those cities are tackling specific resource flow challenges, whether it's wastewater heat, textile, municipal food waste, plastics, energy efficiency, or wood. And through those kind of pilots, we are looking at how to develop and promote solutions, systemic solutions that can make a change from a circularity perspective. In terms of outcome, the project is delivering specific handbooks and toolkits, specific documentations on how the transition emerges, takes shapes, and is implemented at pilot level. We develop also business models that aim to tackle those challenges, and we have a set of capacity building resources. But last but not least, we are also processing and developing specific platforms that actually help us tackle the complexity of managing resource flows. And this is obviously one key aspect in which we want to discuss today. So in basically the next presentation, Adam, you can prepare your slides. We'll look more into details in terms of what concretely is the REFLOW OS that I introduced. So Adam is an Australian internet pioneer, technical practitioner, communication media researcher. He's also an activist with a lot of expertise in application architecture, internet infrastructures, operation, information security, risk management, you name it. He's also one of the brain at Dyn Foundation behind the REFLOW OS, and he will be introducing us to this tool right now. So Adam, the floor is yours. Thank you.
Thank you, Erwan. Thank you very much. Yes, I'd like to begin defining what REFLOW OS is. As Erwan has said, it is an operating system designed to foster and create and manage coordination of distributed and circular value chains. It's called an operating system in almost the traditional original sense of the word, in that it is a system that allows people to operate within a certain field of endeavors. So it is a framework and a collection of tools that to assist people within the stated aims of the system. Moving forward to some details, the REFLOW OS basically consists of 3 components to achieve this. The first component is the REFLOW OS server, which acts as a central collection agent and is the central core of the system. The REFLOW OS client, the first one, the gold standard of the client for REFLOW OS, is a web application that is designed to be flexible and a demonstration and a starting point for users of REFLOW OS to develop and manage and integrate their own business models into the REFLOW OS architecture. It's highly modular and well documented to help with this process. And last but not least, within circularity, within the circular process, continuous monitoring and visualization helps with the creation and the collaboration of the results of circular activities and the opportunities for improving the circularities of local and global ecosystems. Within the REFLOW core, the server part and the communications, there are 4 technical pillars. The first of which is a specification, an ontology called a standard ontology called value flows, which provides a standard language of communication to enable communication of both material and economic value exchanges and flows, from sales to any suitable for any economic model. The second component developed by Dyn is Zenroom, which is a cryptographic engine that enables trust in the exchange networks and allows for verifiable claims of events as well as entry into blockchain and DLT systems to allow for open accountability and transparency. The third and fourth pillar, the third pillar is a standard called ActivityPub. ActivityPub allows for decentralized federated networks for autonomous sovereign participants. Now, what does that mean? It means obviously that within the realm of economic and material activity between participants, a level of control and autonomy can be achieved by the federated network model. In other words, this is innovative in the sense that this platform is not owned by one particular party, and it's not controlled by one particular owner of a platform. There is autonomy within the actions of each participant. The third and last technical pillar is a standard called Graphql, which is a way by which each client application can connect to its local REFLOW OS server and provide minimal but sufficient communication to achieve the ends, thus assisting with data minimization and data privacy. It is also highly suitable for a wide range of embedded uses, from embedded devices and IoT implementations to server and cloud-based solutions. So to dig a little deeper, the core of the value exchanges happens at the standard of value flows, an ontology which assists in the communication of events between participants of a REFLOW OS network. Value flows is based on what is called a REA or REA, or Resource Event Agent Economic Model, which helps break out from the traditional singular corporate economic model of bookkeeping into a more public sphere, allowing for further circularity to take place. Resources can include physical parts, products, consumable items, and so on, including even energy, water, and of course, labor power, work, specialized skills, and qualifications. Economic events are events that occur that change either materials or economic states. So these atomic verbs within the language can signify actions such as consumption, use of a resource, transfer from one party to another, or transporting from one location to another. Processes within value flows are containers for more complex events and resources. And finally, agents are organizations, individuals that perform or at least overlook and validate that certain economic events affecting these resources have taken place. There are three layers of value flows concerning knowledge, planning, and observation. And the flow is signified in the picture to the left, or rather an example flow at each of these layers. The next technical pillar of REFLOW OS is Zenroom, which provides which is a virtual cryptographic engine that provides modern cryptographic methods by which to provide privacy and security in terms of integrity to the economic and material flow exchanges provided by value flows. With modern techniques such as zero-knowledge proof and innovative multi-signature claims, as demonstrated by a deliverable in the project of the REFLOW model, trust and privacy in these flows are enabled by generating material passports, cryptographic proofs that provide a certification that can be passed to blockchains or DLTs that upon each observed event that occurs to materials and within economic flows. So each event can act like an old-fashioned visa stamp within that passport, and the complete history can then be transparently examined. Material passports in an EU sense are also known as digital product passports. And ActivityPub is a standard communication protocol that allows for the federated topological model that REFLOW has implemented. As previously said, this allows the autonomy of individual participants to operate within the network, but also to allow collaboration with wider multi-party circular activities and investigations. ActivityPub is also the stock standard protocol behind some of the other federated models that have arisen over the last few years, known as the Fediverse. In particular, systems such as Mastodon, etc., also use this standard protocol. The GraphQL protocol assists with local clients connecting to their local REFLOW OS instances, and together with value flows, it allows for a network-wide flow of value flows actions amongst participants. So together with this model, these technologies put together allow the breaking of traditional siloed organizational boundaries, as mentioned within the REA model, breaking through the traditional double entry bookkeeping system of economics. Finally, Zenroom, together with value flows on top of this federated network, allows for complete end-to-end tracking and tracing of material flows and economic flows, represented by this example diagram, so that the material passport at each change, at each state of a resource, whether they are combined as part of a recipe to produce a new resource, and so on and so on and so on, this system then allows later auditability and understanding of complete food to fork, natural resource to final product and recycling and beyond. The two processes of tracking and tracing have real world advantages in terms of efficiency of circular activity of products. So new product research can happen from things that can be reused, and collaboration upon the product design and construction. And the tracing backwards helps with such application use cases as redistribution of income, and of course helps with reputation within the network, having these past events and achievements recorded within blockchains. So in summary, REFLOW OS provides to the pilots and users of the system decentralized federated networking for exchange of these flows amongst autonomous peers, a standard shared vocabulary for producing material and digital product passports across their full life cycle, with Zenroom's state-of-the-art cryptographic verification of these material flows that can be integrated into blockchain technologies for transparent trust and reliable auditing through material or digital product passports. And finally, for the management and visualization tools, there are tools to help aggregate the material flows to aid in the discovery of further circular possibilities amongst the participants and to optimize other practices, circular practices across the material and economic flows. So with that summary, I'd like to
yes, thank you,
end
Adam.
there. Yes.
So basically, Adam, you just told us exactly what are the key technical pillars of that REFLOW OS. So in our next two presentations, what we're going to be doing is actually learn about how concretely those pillars are implemented on the ground. So our next speaker is Stefano Bocconi from VER. Stefano is a software engineer. He has particular interest in AI, artificial intelligence, data analysis, and decentralized systems. He's been working as a researcher in computer science in several universities in the Netherlands and in Italy. And he will be telling us, with also his colleague Taco, how they've been implementing REFLOW OS concretely on the ground in Amsterdam with the textile challenge that is actually faced by the city. So Stefano, the floor is yours.
Thank you very much, everyone. So, thank you for introduction. As you said, this work I'm going to present is joint also work with my colleague Taco van Dijk, also the VAG, also present among the panelists today. So, what I'm going to present, I'm going to talk about what we have done within REFLOW, one of the use cases of REFLOW in Amsterdam, which is dedicated to the textile industry. Specifically extending the textile life with the swap shop. So just to give you an idea, of course, everyone presented the broad context of REFLOW. In Amsterdam, we focus on textile industry. And why we focus on the textile industry? Because as other industry, the textile industry has a high environmental impact, which is throughout all the process that of the production of clothes. So from just when you produce the fibers, when you process, also when you process these fibers into making a fabric or textile, and also when this clothes eventually end up to the customer. So their usage also has an environmental impact, like of course washing, drying, ironing, and this kind of activities. So basically, what happens is like in the context of global climate change, we cannot afford to have a high environmental impact in any industry, and in particular also the presentation of in Amsterdam about the textile one. So we have to try to optimize resources so that the energy and resources are not wasted. So having given this general context, now in this very complex slide, you see basically what is called the material flow analysis that has been done specifically for the Amsterdam city. So here you see on the left side the quantities of the raw materials when they enter the system. Let's say it is a complete life cycle of the textile products. It starts with the materials, so you have natural materials, plant-based, animal-based, or artificial. Then it goes into production, then into distribution, consumption, and then after consumption, when they are discarded, there is a collection of the items that can end up in several destinations. Let's call it. This is that is going to be. I'm going to explain you more in the course of this presentation. So you can understand that in every of these steps of the production, there is an impact on the environment. So it's good to try to reduce the environmental impact in any of these steps, but specifically in what we do in Amsterdam for the textile. We concentrate, if you look at basically, now I zoom in the right part of this previous graphics, you see that most of the consumption is for household consumption, and also, so this represents a big share of where the textile ends up by, let's say, after being sold, basically. And you see also that if we look at what happens to this textile after the consumers have used it, the household consumption has happened, basically you see that the biggest part of it is just gets collected together with the municipal waste. So it's not separately collected, but it's just thrown together with the rest of the garbage. So it ends up being incinerated, which is, of course, it's a loss of resources. The second flow from which the textile can exit and the life cycle, so I get to the end of life, is by being properly collected, so separately collected in collection containers. But even then, so this is a smaller part, of course, unfortunately, but also some part of this correctly collected, let's say, textile also ends up being incinerated because of problems like, you know, when they collect it, there can be some polluting effect, like other clothes can be polluted, or some other spurious garbage can be thrown in these containers, for which you end up still incinerating the textile. So these two end of life situations, which are indicated in the slides on the right with the two red circles, are what we don't want, because basically the resource ends, the life cycle cannot be reused, and also contributes to pollution, basically, with the CO2, and I mean, because of incineration. Then the bottom one, the bottom cycle that you see circled in green, is what we are trying to, you know, increase, because in this circle, two things happen, or two dimensions happen. First, the item is not thrown away, but is reused, either reused as such, as a piece of cloth, so wore again, or maybe transform back to the basic materials and reused and re-entered the cycle as a raw material. And this can happen in two dimensions, let's say, either locally, as you see in the slides. So this happens either as a raw material or as a piece of cloth locally, or can be exported to further use. Of course, the most ideal situation is where basically you reuse locally, so you don't, you know, involve other consumption of resources, and you don't basically lose the value of the resource, because you still use it as a cloth. So this is a setting, this advantage we try to get out of the life cycle of the textile is the setting for the swap shop. So what is the swap shop? As the name might indicate, is a shop, basically is a shop where you can bring your second-hand clothes to be sold, and you can exchange them with other clothes. So how is this contributing to the sustainability, basically, of the textile industry? Because by doing so, you extend the life cycle of a particular item. So you do not basically create a need for more raw materials to go into through the process and all the phases. Thereby, you reduce the material which is being circulated and the environmental impact. And also, a secondary advantage of the swap shop is that they also take care of properly collecting when the item, when the clothes cannot be worn anymore, because it's come to the real end of life for the clothes. They take care that this can be collected properly and sorted by textile companies, so that it can enter again in the cycle as a raw material. So by this, you know, creating these two important effects to reduce the environmental impact of the textile industry. Specifically, how does the swap shop work? So basically, you bring a maximum of 5 items to the shop, and then in change for these items, you get the swaps, which is the currency they use, and you get more swaps depending on the quality, you know, or if it's particular piece of cloth, you get more swaps than if it's just a very, very normal one. So you get with this amount of swaps, then you can reuse it in the shop, and you get basically €1 discount for the maximum of 50% of discount per item when you want to purchase another cloth that is in the swap shop. So this is basically how it works, the business model of the swap shop. And now let's say we make a connection to the REFLOW OS that was introduced and explained by Adam. The swap shop is an existing initiative, but so what is the advantage for, why is the need for REFLOW OS for the swap shop in particular? Because the swap shop wants to keep track of the items. So you can imagine that the swap shop has visibility of an item when it's in the shop, but when it exits and possibly re-enters because it's brought back by a customer to be swapped again, they lose this kind of, if you don't track the object, you lose this knowledge that the item might be re-entering your shop. And also they wanted to have some insights of the motivation of the customers. So why somebody decide to, to bring very close to the shop, how much time it takes maybe to make, let's say, to change your mind about the clothes, or to get bored about an item and bring it back, and this kind of stuff. And basically they wanted to associate a story to each item, because with the assumption when you can associate a story to each item that circulates in the shop, the item gets more attractive. It has a story so to tell, not only as an object, but also through what has happened to this object in the past, let's say, the past users. So what is the solution that we came up with? Exactly to use basically REFLOW OS and also let's say the value flow ontology or vocabulary, to use another word, as Adam described it, to model this whole flow, basically, what happens to the items when they are in the swap shop, when they exit the swap shop, and keep track of what happens by using REFLOW OS. So now we get into the details of the application that has been developed for Amsterdam using REFLOW OS, which starts basically when an item enters the shop. So an item enters the shop, they stitch a QR code on it, whereby they associate to the item an identifier, a QR code. This identifier can be read, scanned with your mobile, and this leads to a website which is dedicated to this item. Of course, as you've done, when the object enters the system, the web page is empty, because there's no data. So this is the first moment of contact between you, if you want, the digital world and the physical world. So basically the physical object enters its digital twin into the system, which is at the moment empty. What happens is, like, now we zoom in a top part of the web page. So the web page invites the user, asks the user, if you are the owner of this garment, please have a chat with our swap bot. And if you click then on this link and you have Telegram installed on your mobile, this is a prerequisite, you enter in a discussion between you and a swap bot. So a bot that engage you in ask you questions to basically fill in the information about the item that you just collected in the swap shop. And the question that you ask is, what kind of a garment it is, what model, what size, and all these kind of details that can, provide some kind of details and a story, also start to make a story for the garment for the web page. This is at the moment when the item enters the shop or leaves the shop. The interaction then are not, they don't end up there, because the swap shop of the swap bot can still contact the owner, inviting them to update the information about the item, which was part of what the swap shop wanted to know, just part of a tracking of the item also outside the shop, and also understanding the motivation of the customer. So basically presents the user, if a user wants, of course, to reply to this question, with the question that pertains to the fact that maybe the customer has swapped the item, or has been the garment has been worn somewhere in some occasion, or care means it's being washed or repaired, or any other information that the user wants to associate to the item. It can do it with the dialogue with the swap shop. With the swap bot. Everything all these interactions are recorded in the system, and this is a CMS which is behind the web page that you just saw. So basically, there the swap shop can do a kind of an editorial control of what what information is associated to the item, and everything. So this is in the middle screen that you see on the slides. On the right side, you see the effect of this interaction with the user when the page has been filled in and has a story. In the specific, I brought this in Montmartre, the place of my first kiss, that makes, let's say, that completes the story and makes the item more attractive. How does this, or where is reflow in this, all of this? So when every time that there is an interaction with the customer, which is represented by this, multiple choice option that the user can engage with the swap bot, and the user enters information as a consequence of the swap with the interaction with the swap bot. This is modeled in the REFLOW OS and gets stored all of this information is stored with the identifier that we enter in the system when initially we associate the QR code to a sweater in this case. So everything is kept track, and this tracking basically fueled and powers the keeping track of a narrative associated to the item. So this is how it works, and how is the tools of reflow contributes to the track and trace, and specifically to the swap shop wishes and needs. This is the current state. So this application is going to be tested with a selected number of customers starting from the 1st of March, so very soon. Other features that I didn't show you, but they are included in the application, is that the bot can contact user to invite them. I mean, this you saw basically that the bot can contact the user to update the information with any news, but also the bot can ask also quizzes about sustainable behavior, specifically in a textile domain. So, for example, about washing or about discarding clothes. So this contributes to the awareness of the customers of the workshop. So these are like more features that are planned, that are to be tested with the real user. And this, if we zoom out, let's say this is the concrete experiment which will be carried out soon, has been tested and will be carried out with the real customers. The big vision where this finds a place is that we would like to track the items not only when they are in this cycle of being in the swap shop, being swapped and then coming back to the swap shop, but also what happened when these items exit this cycle, and more specifically when they are discarded and end up in waste, which is modeled on the right side with this value flow vocabulary in the second cycle from the top to the second down. And also when, or ideally when they are not discarded immediately, but they go through sorting and recycling by other companies, which is the third cycle that you see on the slide. So when they are not reused without losing their original value. So basically, if we can do this, we can involve several stakeholders to map these items throughout this extended life cycle, then we can have a better picture of how textile moves in these cycles, and also provide quantitative information to people that have to decide intervention, like you can imagine policymakers, but also people that can say business opportunity, or people that can do initiative to, let's say, encourage the virtuous, the better cycles to reuse and recycle of the material. So that was my presentation. The team, I just shortly present you the team. You can read the names of the team. Has been a collaboration between the Amsterdam Reflow team, which, on the left, and the swap shop team. So the people from the founded the shop and the work at the swap shop, which you see on the right. And I think I am on time, so I give
Thank you, Stefano. So we've seen one application, one example on what REFLOW OS can allow to do concretely with supporting the track and trace of textiles in the context of swap shop. And now Enrico from Milan will let us know a little bit more about some application in the context of food waste. So Enrico, just in a few words, he's working for OpenDot, has a background in design and engineering, product design, graduate from Politecnico di Milano. He's also known for having coordinated the first Italian Fab Lab back in 2011, right? And at OpenDot, he currently supervises European and international projects related to the topic of open source health solution, and obviously focusing a lot also on circular economy. So Enrico, the floor is yours.
Well, thank you, everyone. Thank you, everybody. It's a pleasure to be here and have the chance to tell you what we're doing in Milan. Actually, Milan is doing much more because the pilot in Milan involves other partners as well, starting from the municipality and another fab lab that we work with called WeMake, and a Polyfactory that is a research center within the Polytechnic of Milan. So what I'm talking about right now is not the entire pilot, unfortunately, but just one of the solutions that we developed. And the context in Milan is strongly focused on food and food waste. Food waste is a very impressive problem when you start to dig in because of the numbers and because everybody eats more than once a day. So it's really something that involves everyone. In particular in Milan, we focused on Sogemi. Sogemi is the largest wholesale market in Italy. And when you check the numbers, those numbers are just impressive. So every day there's something around 2,000 tons of food passing through this market and goes, it's a B2B market, so wholesalers to restaurants, supermarkets, and so on. Out of these 2,000 tons, a very small quantity of food can get wasted. But even if it's a small quantity, we're still talking about a few tons per day. So it's still definitely interesting to dig in. And in particular, Milan is working on donations as a strategy to reduce food waste. Milan has a very interesting team inside the municipality that is the Milan Food Policy, and they pushed collection of surplus to be donated since 2016. So they have a lot of experience on the topic. And together with them, there are the Banco Alimentare, Red Cross, and other associations that collect and redistribute in the territory. So this project evolved into the neighborhood hubs. That is a project from the municipality. These centers to collect and redistribute donations that actually got a very important prize recently. So the entire city is working on the topic. And we focused just on one part of this ecosystem that are the donations within Sogemi. So what happens within Sogemi? Basically, the market opens around 3 in the morning, so it's really very, very early, and they close around 10. So the entire reselling process happens basically during the last hours of the night. And when the morning comes, it's time to close, clean up, and decide what to do with what you haven't sold yet. So the wholesalers during the last hours, more or less, they have to decide what to do. Sometimes they throw away what they can't sell. Sometimes they just refrigerate it for the next day. So in this moment, there are some associations that can step in and collect the leftovers, what hasn't been sold. In particular, within Sogemi, there is a super nice group of people called Recoup that goes stall by stall to check if the wholesaler has something to donate. Now, this process is really time consuming. Communications is not easy, it's not efficient. They can't check all the 200 stalls. The stall owners, the wholesalers forgets about telling that there's the possibility to get donations and so on. And at the same time, Recoup, with the donations that they collect, they sort them out, so they are sure that the quality is still very high. And then they re-donate the donations to other associations outside of the general market, such as the Italian Red Cross, that redistribute these donations to the family needs. So the system is kind of complex, and within the entire process, nobody's tracking any data. So we decided to step in with the solutions that we called Botto. It's basically an automation of the communication system that is already in place. So we really tried to fit within the context in which we were working. And this gives us the advantage also to be able to track all the distribution, the redistributions that we got. So the project is basically made out of four different elements. A physical object, so an IoT device that is actually installed within the wholesaler stall, and 3 Telegram groups automated with a bot. So 3 different groups because they refers to 3 different actions, let's say so. So just to have an overview, I can show you this brief video. So everything starts in the wholesaler stall, where there's the device. So the wholesaler can select and say that they have a donation. They can tell how much this donation is, more or less, is an approximate number of boxes, and what's the reason why they are interested in donating this. So this takes less time than call the waste manager to throw away everything. These notifications is automatically sent to the first Telegram bot that just notified to Recoup that someone, and that's also the name of the person that donated, is willing to donate something. So if you accept it, then these informations can be refined, expressing what kind of vegetables and fruits you have, how many boxes, the exact number, just to be precise, double check who donated. And at this point, you recorded the donation. So when the donation is recorded, you can start to sort it out. After the sorting, you can say, okay, initially I had 220 kilos of apples, for instance. After the sorting, 210, that means that 10 kilos were not good enough to be eaten. At this point, you can record a donation that is ready to be distributed. So if you want to redistribute these donations, you can say how much you want to redistribute, of course, so the entire donation part of it, distributed in a different moment. When you've done this step, then the message goes to the next Telegram bot, in which you don't have just Recoup, but you also have the external associations, such as the Red Cross, that gets a notification about how much food is available. If you accept it, then this transaction will be recorded when you actually collect it. So everything is double checked and everything is tracked. And this is the big improvement in the process. At the end of the operation, when you collect the food, the donation, sometimes is required to produce, let's say, bureaucratic documents, paperwork. And this is another highly time-consuming operation. So we automatized it, creating the documents from the data that we already tracked. So this process simplified a lot the entire system from start to the end. So the first object that I showed you was the IoT device. Is based on a ESP. And as you can see, we 3D printed the first batch. Of course, the numbers are not big enough to start an industrial production at the moment. And the interaction is very, very simple. You have a tiny speaker, a buzzer for audio feedback, and you have a big LED just to tell you if the donation has been accepted and the state of your donation. And then the 3 Telegram bots that I told you about. The first one is just for the internal management within Sogeni. The second one is for communicating between internal and external, so the associations within Sogemi and the associations outside of Sogemi that will redistribute the donations. And the third one is to print and generate the automatic documents that might be needed. The entire process, as I said, has been co-designed. So it's not just us going there and tell people, okay, the solution is this. Technologies, it's amazing, but it can be invasive and not always accepted. So it was really important to be there, check what they do, the kind of job that they do, bring paper prototypes. The entire flow was fundamental to engage them and to actually understand better what happened. So 2 days ago, we were in the general market very early in the morning to collect donation and see how it works, to understand better again. And these are the partners that we engage in this first deployment. I'm saying deployment because the objects are already there, and we started to collect some data. So just to simplify the process and understand exactly what happens, the first step is the wholesalers that can signal a donation. The message gets to the first bot. I can accept it or reject it. It's important to give the possibility to reject it because of the time. So wholesalers are always in a hurry and they need an answer within 30 minutes. Otherwise, it's easier for them to just dispose of what they can't sell. Next step is to sort out what I collected. This is very important operations because Recoup is basically the only association doing that. The others are sometimes too much in a hurry. It's very time consuming. So either the donation is, let's say, perfect or close to perfect, or they will not accept it. So there's the risk of wasting food again because of that. And then we have the interaction and the possibility to post the donation to be collected. The last step, as I said, is the possibility to collect the donations and print out the documents in almost automatic, basically automatic way to simplify even more the entire process. So during the entire process of donations, you can see what kind of data that we track. So at the beginning, we know who donated, we know when, we know a rough estimation of the quantity, and we know why they want to donate it. These are the informations needed to activate the process. Further on in the process, we move from the number of boxes to kilos. We move from a general fruits and vegetables to apples or the specific products. And the entire process is tracked. So during the few days that we have been there, we started to collect some data, and it's very fascinating to see the numbers and also very exciting. So this, I think, was the last visualizations that we collected. You see all the products that has been donated with the quantities. So overall that day it was like 5,000 kilos of food. Not everything has been saved, but if you get the details, one product was basically very compromised, and that was the one thing that compromised the entire collection. So 90% basically of what's been thrown away was just one product. But even when you consider the amount of food that couldn't be redistributed, you still have a great result. And it's also fascinating to see how the data shows us the dynamics of donations. So nobody were tracking this before. So what are the next steps in this? Well, we realized that when you start to show data, you can really push the creation of new policies or use them as a communication tool. So we really want to see the evolution of a law that is already in place in Milan, that it's about tax reduction for donations, but it's being slowed down by the paperwork connected to it. For the association, it's important to prove the impact that they are doing, and this is again comes from the data that they collect. And SOGEMI can finally take decisions that are based on the data and not just on a vague perception of what was going on. We are modifying what we've done to track better what SOGEMI is doing, and this is another step that is very interesting in the next future. And then, of course, we are very happy to explore new context or similar context in other general market or in other cities, because what we've done is really based on the Milanese case. This gives us the possibility to bring on the research we are doing on food waste and food loss measurements, that it's a hot topic even at the European level, through co-design and technologies the way REFLOW actually did that. So last but very important to me, the team behind this project is big, and this is just people from Open Dots involved in that, but of course thanks goes to the other partners in SOGEMI, the municipality, the other partners in the local pilot of Milan. And with this, I just thank you for the time and give back to everyone to continue.
Thanks a lot, Enrico. Great presentation. Very interesting to see how concretely in details, in a specific context, this kind of data solutions, bring specific benefits to tackle food waste. So now we'll take actually a little bit of a zooming out process. So we were really much into the details in the last two presentations, but now Stefan from the European Policy Center will actually give us the bigger picture of what we are talking about when we talk about digitalization and circular economy at EU level. So Stefan is policy analyst on the Sustainable Prosperity for Europe program. He's been working for many years on environmental policies related to smarter use of resources, and obviously focuses on circular economy and digitalization, and is gonna let you know exactly what's the next steps, what's the big picture at EU level. Stefan, the floor is yours.
Thank you so much, everyone. Happy to be here to discuss this very important matter, and I believe we almost ran out of time, so I'll really try to be super short and leave some time for the discussion if possible. So indeed, I'm a policy analyst working at the EPC, which is a Brussels-based independent policy think tank. And among many other topics that we cover, we also worked on the twin transition. So how digitalization can support circular economy, and how can we green ICT itself. And we published a number of papers, organized numerous discussions, and one of the most important subtopics we encountered was the question on information transfer. How can we actually improve information transfer with the support of digitalization to support the green transition, and we especially worked on the circular economy transition. And so basically this is how we envisage it. So information transfer is crucial to achieve circular economy because of because of the nature of the transition. Everything is interconnected. You need to connect different stakeholders, different stages of the value chain, and digital tools can make information transfer more efficient. And this is part of a bigger picture, looking at the policy level, the European Green Deal, which is an overarching EU's growth strategy and also a pathway towards achieving its climate environmental goals. As circular economy is part of it, and basically the green, as mentioned, green transition and digital transformation can be aligned to support circular economy, and digital information transfer plays a key role in this process. This is how we see it at the EPC. So there are prospective tools that are yet to fully be scaled up, like digital product passports. There are existing digital tools for information transfer, like online platforms and databases and so forth, that can then support different stages of the life cycle and support circular economy. And these are, I'm just shortly list them. So from online platforms to Internet of Things, blockchain, digital product passports, there are many opportunities to support information transfer for circular economy. And a lot of them apply one way or another to the city level, to the local level. I would just highlight, for example, smart bins that can inform waste operators when the bins are full, so they can then be so that the waste collectors can come and pick up the waste on time. That's just one of it, but there is so many other, but I don't really think I have a time to go through them at this moment. I'll be happy to share the presentation, by the way. When it comes to challenges to information transfer, digital information transfer, one is the lack of access to good quality data. Then most importantly, it's the question of our data protection. It's difficult to share data if you're concerned about intellectual property rights and personal data. So you need to share data, but we need to square the circle, how to share it, and then to also account for these data protection concerns. There are also other complexities need to be managed. The supply chains are quite long, transnational, the different actors involved with their different motivations to share, not to share data. And also a slow progress in digitalization in general. In Europe, we still need to increase our internet coverage to begin with. We need to improve our connectivity. We need to roll out 5G and many other digital infrastructure components that can actually support this digital information transfer for circular economy. So looking at the policies, what we see at DPC as a bigger vision is to establish a sustainable digital information system for circular economy by 2030 as a general overarching goal. But looking at more specifically, the EU is currently working on these common European data spaces that are a sort of a mix of technical and policy solutions to facilitate data sharing. And one of these, this will be one data space, but there will be different aspects to it, and data space or data spaces, we can also talk about that, will also support circular economy. And what we need to do, this is already happening, it will take years to complete it, but what needs to be done is really ensure that it's effective, that it doesn't end up just collecting data for the sake of collecting data, that it's not just one more administrative burden, but it actually adds value, that it brings about the change that we want, so that different stakeholders get the information they need to support greater circularity, and also to see if business opportunities could be explored in this regard. Then rules on digital product passports, they build on the data space, but they're a bit more something extra, because it's about establishing unique identifiers for each product, like a ID number or a passport number that you have. Then rules on digital tags, and what background information will be provided. This will be important to harmonize it at the union level, and also looking at it globally, so that we have similar rules that can support information transfer within the value chain, but also across different value chains. And then using different economic tools, financial tools, to support research and development and upscaling of prospective businesses. And for example, REFLOW is a good example. It's supported by Horizon 2020, and we simply need this kind of a financial support to boost these developments and upscaling of businesses that can use circular economy information transfer. And then it mentioned lead global efforts. We can't achieve circular economy in Europe alone. We need global standards, and the EU can lead by example. So these are some of our publications. They're all publicly available at DPC's website. There are more, and we continue working on this topic. So thank you, and happy to hear any questions if we still have a bit of time. Thank you.
Thanks a lot, Stefan. Very, very concise, but full of information presentation. So maybe if some of the audience has a specific question to Stefan or to any other panelist, please do so right now. We can take maybe another extra 5 minutes in terms of time. Maybe in the meanwhile, I was just wondering, actually, Stefan, since you were presenting very briefly like different upcoming emerging solutions that may be similar or slightly different from REFLOW OS, do you see that in the next future there will be some sort of one key solution, one standard that will sort of take over, or do you see more like EU going into setting up specific requirement features that all those solutions should actually have implemented to make it work?
Well, thank you for this question. And this is indeed something that is yet to be fully defined. I mean, this common data space is the main topic to address in this case. And we still don't know what it is. There is no common definition of the data space, but there is a sort of a intuitive grasp of it, what it will entail, you know. And how I see it, so from previous discussions, is that it will entail certain common rules and standards, but it won't be uniform. So it won't be all prescribed, made mandatory, or there won't be a single app or a single solution in that sense to cover everything. For me, more like there will be certain rules on ontologies, on certain data standards, data governance rules, but it will also be quite flexible. And you can use, there is no, how I see it, this not the idea is not to have like one database where everything will be loaded, you know. That's not the idea. You can also use decentralized tools like blockchain, and I think REFLOW also is part of that kind of an idea. Federated networks. This is definitely part of the story, and the idea is to work with businesses. And my feeling is that the Commission is really trying to build it bottom up, with some common standards to facilitate information transfer, but some of them will be specified in very, you know, like niche settings and with specific legislation or voluntary approaches. And I think there won't be like one solution, but there will be some common standards that will help you also share data, access data, process data. So that would be how it will go, but it will take some time to actually to finalize these requirements. Now, legislation, Data Act is very interesting. Data Governance Act is interesting to look at it, but there will be other solutions as well. Sustainable Products Initiative, now expected end of March, will introduce general requirements, digital product passports. So it's interesting to follow this up and you know, stay tuned for any further developments.
Thank you, Stefan. There was one question or comment actually from Michael in the Q&A, asking basically that we need to validate the data tied to the digital product passport. We know that clothes labels, for instance, can be fraudulent. So any remarks or any feedback from Stefan or maybe from other panelists here about the need to validate the data? Can those actually solutions platform, you know, support the validation of data, or is it still something that we need to work on?
I can just briefly say, and happy for other to supplement or correct how I understand, you know, it's good to have the auditing in the very beginning, and but the blockchain can then help with the rest. Once the data is inserted in the beginning, then it's actually there to ensure transparency and immutability of data. But then the first data entered, to my understanding, that requires some kind of a third-person auditing, but then it makes the further auditing processes much easier along the supply chain. That's how I understood it so far.
Any comments or remarks from Adam, maybe?
Yeah, I'd just like to add to follow up to that. Yes, I mean there's always inaccuracies when we cross the air gap from the real world into modeled into the digital world, but with I believe with an atomic model such as the value flows RIA model, we have an opportunity with every event that happens that validation can happen in parallel to a signing process. So with multi-signature cryptographic schemes, you can do that, but also in serial over the causal chain upon products, so that if a receiver of goods disagrees with the claim of a producer's good, then further actions can be taken either outside in the legal system or internally within a returns exchange or query. But of course, these are all evolving concepts and standards, and it depends upon the particular business logic of the applications and the participants involved.
Thank you, Adam, for this final comment. We're getting close to the end of this webinar, unfortunately. 1 hour is always too short. One thing still that I would like to address is that REFLOW as a whole is coming to an end very soon, but we have a final event. It's a 2 days event. One day will be online so that everybody can actually really get a bit more information on all the things that have been happening at the pilot level. We've had 2 examples of applications here. There's like many others in different cities tackling beyond food waste and beyond textile. We have applications related to energy, to plastics, to wood. So if you're interested in learning a bit more about what has happened and what is the future of this kind of concept and approaches, please join us by the end of March, either offline in Copenhagen directly or online, obviously through the usual channels. So please go to the reflowproject.eu website to get more information about the content of the agenda. Otherwise, this webinar will actually be published as well on the website. So if you want to have a bit more time to look at it again and get a bit more content on the presentations, it will be online. And that's about it from me. I think I want to thank you, all of you guys. Warm thanks really for this super interesting presentations, and I hope we can see each other again during the final event. And for any other information related to Reflow, please just go to the website and register to the newsletter. There will still be more news and updates coming up. Till then, thank you, and have a nice continuation for today.
Thank you.
Thank you. Have a nice day.
Bye.